In this video, you will learn how to write an equation, a polynomial to be specific, given the degree, the leading coefficient, the zeros, and y-intercept. So let's solve some sample problems here. All right. Write an equation in factored form of polynomial p of x with a degree of 4, a leading coefficient of 1, and given the zeros 1 0, negative 2 0, negative 4 0, and 4 0. All right. So factored form means that if we're given zeros, say 3 0, which means x is equal to 3, factored form is just x minus 3. Then degree of 4, meaning the highest exponent of the polynomial is 4. So let's say your polynomial is f of x, or y equals ax to the 4th, x cubed, and so on. So the highest degree here is 4. And the leading coefficient is 1. That means the value of, or the coefficient of the highest degree is equal to 1. So in this case, we have a, and a is just equal to 1. Then we're given the zeros. The zeros are the values for x when y is equal to 0. So let's solve this problem. So given that the equation has a degree of 4, so that means it has 4 factors. And we already given the 4 zeros here. So we can directly write the factors here because we're given the zeros. That means this one, the value of x here is equal to 1. So our factor would be x minus 1. And then this one is x equals negative 2. So this is x plus 2. Then x equals negative 4. So the factor is x plus 4. Then we have 4 0, which means x is equal to 4. And then her factor is x minus 4. Then now we can write our polynomial equation p of x. P of x is just equal to a times x minus c sub 1, x minus c sub 2, x minus c sub 3, x minus c sub 4. So c1, c2, c3, and c4 are the zeros, are the coefficients. And it's given here that the leading coefficient is 1. So a is equal to 1. Therefore, p of x is just equal to x minus 1, x plus 2, x plus 4 times x minus 4. It says in factored form, so we don't need to expand the polynomial. Okay, let's solve another problem here. So write a polynomial equation with a degree of 3. Is 0 located at x equals 4 and a y-intercept at 0, 60. So an equation with a degree of 3, so that means that equation has 3 factors. And recall or take note that for all x-intercepts written as c0 or x equals c, the polynomial equation has that factor x minus c. So this is the factor. Given that the equation is of degree 3, so that means there are 3 factors. And 1 0 is given here at 4 0. It's x equals 4. This implies that x minus 4 is one of the factors. Since the other two zeros are not known, we can write the two factors as x minus c1 and x minus c2. Now we need to find c1 times c2. So our polynomial would be y equals x minus 4 times x minus c1 times x minus c2. But we're given here the y-intercept at 0, 60, then we can just plug in the ordered pair here. So let's plug in 60 for y equals 0 minus 4, 0 minus c1, 0 minus c2. So 60 equals negative 4 times negative c1 times negative c2. And we have 60 equals negative 4 times negative c1 is positive 4c1 times negative is negative 4c1 c2. And then we divide both sides by negative 4. Then this gives us a value for our c1 times c2, which is equal to negative 15. Therefore, the product of the two coefficients from the two factors is just equal to negative 15. So let's write again our equation y equals x minus 4 times x minus c1, x minus c2. So our factors can either be negative 5 times 3 or negative 3 times 5 or negative 15 times 1 or 1 times 15. Negative 1 times 15. So you can choose from any of those options. So we can write our factors as y equals x minus 4 times x minus 5 times x plus 3, or y equals x minus 4 times x plus 5 times x minus 3. And you can also use negative 15 and positive 1, or positive 15 over and negative 1. Actually, this problem has choices, but I just forgot to upload it. Alright,